one of the key design inspirations for this, one of the key design drivers, was trying to bring general aviation back up to the level of design quality, the level of design standards that we're all akin to in the automotive industry and every other area of our life. So as you go and you get close and you experience the machine, you'll find that we've got A-class surfaces everywhere, automotive levels of design in terms of the surfaces and the detail that go in there. We've made a proper helicopter. The forward flight speed of helicopters isn't, for operational speed ranges, isn't limited by advancing tip Mach numbers and retreating blade stall. It's actually that they're just really draggy. So one of the things that has been a key design philosophy all the way through the program is retractable undercarriage to get those out of the way, cowl in the main rotor pylon, get that out of the wind. So when you look at that beautiful piece of sculpture on the top of the airframe, that's not artistry. That is essentially an aerofoil profile, if you were to cut it in section, into which we've sculpted in the inlets for the engine and the exhaust to get the air through the system. Yeah. And so we've got two pins out there that transfer the lag motion into the cuff and into the lag damper. And those two flaps that you can see at the root of the blade are essentially your blade fold mechanism.
You know, I was really surprised.
Yeah.
I saw these things being installed, and they were quick. I mean, they were simple.
You should have seen it the first time we did it.
But as you said, it's just two pins and those clips, and it's secure, but it's so simple.
Yeah. So with helicopters, this looks like a spaceship, right? But underneath it, it's quite simple. You know, there's a lot of really sophisticated design work gone into making a simple structure. To get a good forward flight speed, you have to be able to keep the fuselage level in forward flight. So we've inclined the mast forward quite substantially, and then we've got a very high authority horizontal stabilizer to keep the ship level. With the tail rotor itself, we've got a large chord blade here, so we've got lots of authority. People
like what kind of authority are we talking? Because I know that one of the common questions is, shrouded tail rotors, they can lack in authority.
No.
What are we talking about as far as what can we do with this?
This has been designed to be able to maintain directional control at 35 knots from any direction at max gross weight at 10,000 feet on an ISA plus 15 day.
So you're hovering out of ground effect at 10,000 feet, winds blowing from any side or the back?
This will keep you pointed in the right direction. We've got a frangible tail bumper here.
Frangible.
So this is a part that's designed to protect the integrity of the important bits here and is easily and inexpensively replaced.
So you can replace this?
Yeah, if you bump it and damage it, you just replace that bit. What we've got in the lighting system on HX50, you've got conventional navigation lights, so you've got a simple LED cluster at the tip of each wingtip and your white lights in the tail. Your anti-collision light is split between front and back to make sure we cover the full 360 range that you're required to. Yep. You've also then got landing lights. So the nose cluster has the short focus and long focus narrow beam that illuminates where you're going, whereas the side pods here give you a broader view of what's around you for when you're going into more confined areas. And then as part of the signature lighting, we've got the lighting stripe that runs down the side that delivers some of the navigation light functionality. One of the options that you can select for the wheeled version of HX50 is HeliMove, which gives you the ability to drive this thing electrically on the ground via your smartphone or the plug in the cabin. So it just means getting it out of the hangar and putting it away again, and much simpler than it's ever been before.
So you're saying I could sit inside the helicopter, press a button, hangar doors open, and I could drive it into the hangar from inside the helicopter?
Yeah, that's the whole point. So again, if you look at the design of the skids, we've got a fence on the leading edge of the front, and again, that's just about keeping the flow attached to the fuselage, and it's about getting nice streamlined flow over the skid fairings.
I found a backpack.
There is enough baggage space in this helicopter for my wife.
Backpack?
Okay, let me demonstrate.
Come on.
I gotta get some stuff out of this one.
Come on. Jace, please. It's a little bit heavy, that one.
I thought you were done.
And is that enough?
A backpack. Everything in there.
So you can
Are we going snowboarding as well?
Yeah, there you go. You can really go places in this helicopter. Let's go and take a look inside. The doors are all properly trimmed with door cards. The grey areas, which are the thresholds between the outside and the inside, are all very well executed. And then if you just have a look at the door threshold down there, Rob, we've put proper branded tread plates between the inside and the outside. What we're trying to create here is a cosseting cabin environment that makes you feel secure. The whole cabin is trimmed in the finest quality materials that are available, exactly what you would expect from a premium car. This is the HX50 crew seat. It's the same seat in every position in the helicopter. What we've got in front of us here is an environment like no other for VFR flying. So even though we've got two 15.6-inch screens in front of us, you've still got an amazing down angle. I don't know about you, but I can see about a meter in front of the nose,
Absolutely,
half a meter to a meter in front of the nose.
All the renders make it look like these are really big and they're right in your face.
No.
But they kind of disappear. They're down low, they're back nice, perfect position for them.
They're much lower than they think they are. The Collective is fully integrated with the center console.
I love that.
Now, we get lots of comments about the Collective. Oh, where's my handbrake gone? That's not going to work at all. The whole idea is if you're going to have a center console in a helicopter, then your arm movement needs to be front and back.
I love that.
Otherwise, you can't use the armrest.
Yeah.
So this thing, it's an entirely conventional action. It just moves forwards and backwards. Both the cyclic and the Collective have triggers.
Right.
So the way this works is to move the controls and to fly normally, you pull the triggers.
Yeah.
And then if we take it in terms of the Collective, when you release the trigger, that Collective is going to stay exactly where you put it.
Beautiful.
Now,
Amazing.
as standard, that's just a position hold function.
Yep.
When you've got the 4-axis autopilot, there's some other higher order modes that will manipulate the position of the Collective to hold the input target. We fire into normal operation and say hello to the new Digi cockpit.
Beautiful.
Okay.
Wow.
So if we've also got the iPad again, obviously presenting the iPad front and center in the cockpit.
Yep.
The guys like 4Flight and the other app developers, Oz Runways, for example, do an amazing job of collating all of the information you need for navigation, communication, weather, and all of that. There's no point us competing with that.
Yep.
Let those guys do what they're good at. So we've elected to have provision for the biggest. That's the largest iPad you can buy.
Love it.
So the biggest iPad right in the center of the cockpit there. And this one's running 4Flight. So that automatically syncs with the onboard flight control computer.
Okay.
So the navigation mode from the autopilot will pull that route down from the iPad. One of the comments that we had from customers was that the airspeed being at the bottom of the screen when the screens themselves were very low felt a little bit wrong. So we've flipped the arrangement of the DigiCockpit around. We've now got the airspeed at the top
I like
of the display.
It looks like it's in the right spot.
It feels like a head-up display.
Yep.
We've still got the first limit indicator, our sort of latest and greatest version of that.
Yep.
When you look at this, you've obviously got your a percentage power range. You can pull 100% all day, every day.
Yep.
When you go into the 5-minute range, it will go orange and it will give you a 5-minute countdown.
Yeah,
right
I saw
on.
that earlier. That was nice.
So if we start with radio frequencies, this one's set up with 2 radios.
We've got 2 radios right
So,
here.
yeah, you can click into your radio. It immediately brings up the radio
like that.
page. You've also got the audio panel here. So we can pop the headsets on for a second if we just change from mic to the headset mics for a second.
Yep.
Okay, can you hear me?
Yep, perfect. Loud and clear.
So if you've got a noisy passenger, for example, let's try it. Ruben, why don't you tell us about that time you flew around the world?
Oh man, it was amazing.
So all I can do now is just isolate me and you. You can't hear him at all. So other features, you've got the barometric settings for your altimeter. So the other thing you'll notice about the altimeter here is we've again re-engineered the altimeter so it's clearer than ever before.
Yep.
So if we pop the altitude hold on, the autopilot functions are now on the home page of the IPI.
Yep.
So you can turn the altitude hold function on, and once you open that up, then you can dial in a new target for it if you want to, or just turn it with the puck. Just down here, there is a space that's purposely designed for your mobile phone with a Wi-Fi charger in there as well. So that'll charge while you're flying. And then this final control on the center line is your wheels, your brake release. So the brakes are on by default in this. So the wheeled one will land like a skidded helicopter with you held in position.
Yep.
You pop that down, you'll get a little indicator that shows you that you've released your brakes, and that gives you the ability to taxi.
Nice.
So all very simple, all very elegant. And the two other controls that we've got up here is you've got your ELT, so the functionality for your ELT, which hopefully you won't need. And then we've also got the trim tank control. So one of the ways that we get the CG range that we need to be able to take 595 kilo passengers, 3.5 hours worth of fuel, and fly at 140 knots, is we've got a slightly more advanced fuel system than you have on similar light helicopters. So there's a trim tank in the nose here that behind the scenes just manages where the fuel is to bring the fuel.
So we don't need to do anything. I don't need to be switching anything up.
You don't touch anything. If there's any problems, then the fuel gauge will warn you. You'll get a warning, and you can.
But if it fails, there's no.
There's some procedures that involve you might have to jettison, or you might have to lock it off so that it keeps the CG, and you'll get a warning that'll tell you how long you've got before you need to land, before the CG drifts out. So if we talk about warnings for a second,
can I just stop on a safety point that was really important, I think, for me when I learned it. The trimmer tank is at the very nose of the aircraft, but it's actually not really internal inside the structure of the aircraft. It's actually external to the aircraft,
it's designed to be external to the structure. You can't have fuel in the cabin.
Exactly. So it's completely separate from the cab of the aircraft.
Let's talk about warnings for a second.
Okay.
So this is obviously a very sophisticated cockpit,
Looks like it.
And it's also important that you've got simple, high-integrity hardware to give the pilot critical warnings. So on the top of the binnacle here, we've got a series of warning lights. So just the same as what you'd see in other similar turbine helicopters. So all of the usual suspects on there. And that is really simple hardware. It's a bulb and a wire connected to a sensor that tells you if something's working or not. Now, in addition to this, if you get one of these lights popping up, then we've engineered what we call emotionally sensitive warnings, that will not only alert you to the fact that something's wrong, but for our less experienced people, for people that we're drawing into aviation for the first time, we're trying to give them as much support and help as we possibly can. And so they will tell you not only that you've got a problem, but what to do. In simple, concise language, what to do on your flight when that happens. So we've got 3 500mm seats. So these are the same size as Range Rover seats. Our tallest percentiles can still clear all of the things that they need to. And then just in terms of your seating position, guys, how's the leg room?
Incredible. I mean, I can almost lay down.
Shoulder room?
It's incredible,
Incredible.
Really good.
And
we had somebody 6'6" in here, and they still have headroom.
And again, just from a cable management and keeping the place tidy point of view, the headsets fit on the back of the seats, so they can be tied away. The cables run in between the seats, and again, the idea is you bring it up under your arm, over your head, and it's mounted low on the wall, so when you lean forwards, you're not trapping cables or anything else.
Amazing.
There we go. So that's the rear cabin. So let's move on. Oh, the other thing to point out, of course, is we've got USBs everywhere for people.
Lots of charging in the helicopter.
As people have asked.
We have to.
So we've skipped through a lot of this stuff. Let's talk about the main rotor. Going to a 3-bladed rotor system is a lot more complicated than a conventional 2-bladed helicopter. So I think it's really important for people to understand why a 3-bladed helicopter or a multi-bladed helicopter makes such a difference. So the thing about 2-bladed helicopters is they've got a single pin that goes through the mast. So the only thing that's holding that fuselage in the correct orientation is its own self-weight. So if you have the tiniest gust, it wobbles around like that, okay? So you can see it bobbing around already. Now it's got some stiffness. No matter how I push it, it soon returns to the position that it wants to be. And the reason for that is that the moment you offset the point that the blades are attached from the center of the mast outboard, the centripetal acceleration, or the centrifugal force as people might know it, is trying to keep that aircraft aligned with the main rotor system. We call this the sort of the soul of the helicopter.
Yeah, the soul of the
helicopter.
helicopter.
So all of its characteristics come from what goes on up there. This is what makes it fly like a proper helicopter. So the flapping and the feathering is done by the strap packs. And then the leading and lagging actually happens about this point here. And you've got an integrated lag damper, so a shear lag damper built within the cuff. We can make these parts to the price we say we can. And that's what's powering this sort of renaissance in general aviation that we're
Not just
we're
you
trying
can,
to
but
create.
you have.
Well, there it is.
That's incredible.
There it is. And this is essentially a culmination of our manufacturing capability for producing a cost-effective gas turbine engine. So unconventionally, we have a direct drive starter generator on the front of the engine. This essentially reduces the need for the biscuit box gearbox you have on the front of the engine. It makes the engine a lot simpler. The compressed air bleeds around the combustor, comes into the annular combustor. We have 12 fuel nozzles around the annular combustor that give us great atomization, great performance, great combustion efficiency.
That's going to help get rid of all the exhaust on your tailboom.
That's one of the things that contributes to it, yeah. And then you can see the spray nozzles just inside there as well. So this is the first section of the engine to be tested. So this is the combustion test rig.
So this middle part here, right?
This is essentially this part of the engine here. So this test essentially proves that we can get the fuel into the engine, we can atomize the engine, we can start the engine, we can get stable combustion, and that gives us the basis then to do the gas generator test. The trick to doing this is getting yourself into a position where you can make these parts. And so what we've done and what this demonstrates is that starter generator, we can make all of the parts we need to get the engine started. When it comes to machining precision, highly balanced rotors that run at approaching 50,000 RPM out of the finest grades of aerospace titanium, we can do that within our factory at Hill. So we've now adopted a dual site approach, okay? What we are doing for production is we are going to manufacture in one location, and then fly from another location and just ship the machines for two, and then expand our flying location at a later date into something that can suit all things. So with immediate effect, we'll be expanding our rented space. I can also announce today that in terms of our new home for flight ops, on Tuesday, I think it was, we signed heads of terms with Halfpenny Green Airport to purchase, to lease and then to purchase 10 acres of developed land. Halfpenny Green Airport, being an airport, benefits from permitted development rights. What's important is that we're able to design helicopters not just for our existing private operator base, but for the commercial base that will make operating helicopters profitable again. And our GVTOL strategy has got two prongs to it, essentially. It's how we meet the requirements of a world that's ever more interested in sustainability and making sure that we can demonstrate carbon neutrality going into the future. But it also is going to put helicopter operators back on a paying basis again. And so our strategy is all about how we make the helicopter more sustainable in a world that will have to wait a little while for batteries to be good enough to make an electric helicopter or some of the other configurations truly economically viable in a business that's tough as it is. Okay? The way to think of biofuel is essentially like Mother Earth's battery. Okay? So every year, every day, plants grow. As they grow, they consume carbon dioxide. They scrub the atmosphere of carbon dioxide. But then, whether it's farmed crops or whether it's other crops, they rot in the fields and they release their carbon back again. With biofuels, what we're doing is we're essentially interrupting the process between plants growing and cleaning the atmosphere and plants rotting and releasing it back. End-to-end control of spares, and that also gives us the ability to drive the cost of insurance down to unprecedented levels. So we're working with 3 different insurance partners at the moment to provide a global coverage for Hill Insurance, where we will partially underwrite the values of these hulls to get the cost of your insurance down. We need to make sure that our community is properly supported. And again, an engineer driving an engineering company means we're going to carry stock. It means we're going to have parts so that we can get it out to the world.
So if I have a part that breaks, how long do you think it's going to take me to get it over to Canada?
For consumable parts, so for things that get worn out, we'll carry those in stock anyway. And then it just comes down to dispatch the same day and out. This is our end-to-end strategy to make helicopters pay again.
Oh, nice.
Woo!
I know sometimes we make it look easy, but it takes a lot of people to make these helicopters work. So thank you to everybody. Thank you to our own staff. Thank you to our subcontractors. Thank you to our amazing marketing team. Thank you to everybody. Ladies and gentlemen, thank you very much.
Amazing. Woo!